everyone. My name is Amrita Bhatnagar. I am from CSC department of AKGEC. Today I am going to explain about the concurrency control protocols. Okay. So this is the outline of this lecture. Firstly, we will understand what is the concurrency. Now, next is the problems of concurrency. Okay, we will discuss what is the concurrency and what are the major problems of concurrency control. Then we will see these three protocols which are used to control the problems of the concurrency. Fine. The name of the protocols are log-based protocol, two-phase locking protocol, and timestamp-based protocol. So in this lecture, we will discuss these three types of concurrency control protocol. Okay. Firstly, we should understand what is the meaning of concurrency. Concurrency is the ability of a database to allow multiple or more than one users to access the data at the same time. Meaning, when the database was accessed by the different user or multiple user at a time. Okay, you can say that multiple transactions are occurred at a same time on the database. Then we can say can say that this is the concurrency. Now there are some problems in the concurrency control. You can see we have discussed. We are going to discuss three concurrency control problems. First one is the lost update problem. Second is the dirty read problem, and third one is the phantom problem. Firstly, we will start with the lost update problem. This problem indicates that if two transactions T1 and T2 both read the same data and update it, then effect of the first update will be overwritten by the second update. Okay, so in this example, you can see here, this is one schedule where we have two transactions, T1 and T2. You can see here, first is the read operation, which is going to read a item X. Now, the next updation is X is equal to X plus N. Okay. Now, after these two operations, this transaction is not committed, but next operation, next transaction T2 will start. X is equal to X plus 10, and then it will write the value of the X here. So we can see that the updation done by the T1 is lost. When T2 write the value of the X. So this is the main lost update problem where only second update will be overwritten by the first update will be overwritten by the second update. So now how can we avoid it? A transaction T2 must not update the data item X until the transaction T1 can commit data item X. Okay, so we have to commit this transaction over here, and then T2 will start. Now next is the dirty read problem. The dirty read arises when one transaction updates some item and then fails due to some reason. This updated item is retrieved by another transaction before it changed back to the original value. Now we can see here next example. By the help of example, we can understand what is a dirty read problem. You can see here in this schedule we have two transactions T1 and T2. This is the read item X. X is equal to X minus N. Now this value will be written by the help of this operation write. Now you can see here the value of the X is written by the transaction T1, and this value is again read by the transaction T2. So what it means, the value written by the transaction T1 is read by the transaction T2, but this transaction is not committed. If there is any problem in this transaction or this transaction will fail, so what will happen? Again, T2 is also have to be roll back if T1 will roll back, because the value of the X depend on the T1. Fine, then this is known as a dirty read problem. But if the transaction T1 will commit here, then we can remove this problem. dirty read problem. Okay. How to avoid this problem? Transaction T1 must not read the data item X until the transaction T2 can commit data item X. Okay. Now, next is phantom read problem. The phantom read problem occurs when a transaction reads a variable once, but when it tries to read that same variable, again no error occurs saying that the variable does not exist. Now you can see here, this is the one schedule where we have two transactions. First, in the first transaction, read X. Okay. Next, transaction T2 will again read the value of X. Now what happened? T1 transaction will delete this X data item. Now when T2 wants to read this item X, it will give a error. This is known as a phantom problem. Now, to control the different type of concurrency problems, we will use some protocols. So, in this lecture, we will discuss three main concurrency control protocol. First one is your lock-based protocol. Lock-based protocol in DBMS is a mechanism in which transaction cannot read or write the data until it acquires an appropriate lock. Lock-based protocols help to eliminate the concurrency problem in DBMS for simultaneous transactions by locking or isolating a particular transaction to a single user. Okay, so in this case, we will lock particular item. For example, there is a data item X. Now, we will lock this data item when we are going to use it in a particular transaction, and we will unlock this data item when all the transaction will be completed. So when the particular data item will be locked by a particular transaction, then that transaction only can use this data item, and other transaction will not use this data item until this particular transaction will unlock the data item. This is the concept of lock-based protocol. A lock is a data variable which is associated with the data item. This lock signifies that operation that can be performed on the data items. Locks in the DBMS help synchronize access to the database by concurrent transactions. Now we will see here. Next, we will see there can be two different type of locks. Okay, lock can be of two types. First one is your shared lock. A shared lock is also a read-only lock. For example, if a particular transaction wants to only read the data. Okay, if for example, you can see here there is a transaction T1 and it wants to read the data only, then it will lock the data into shared lock. Okay, so it will allow it only to read the data. The data item can be shared between the transaction. This is because you will never permission to update data on the data. So when you have the shared log on the data item, you cannot update the data or you cannot write the data item. For example, consider a case where two transactions are reading to account balance of a person. The data base let them read by placing a shared log. Okay. However, if another transaction wants to update that account balance, the shared log prevents it until the reading process is over. For example, now you can see here this transaction T1 wants to read a account balance of a person. Then we will lock this data item into a shared lock system because it wants to only read the reading operation will be done here. So, but if we want to write the operation, then it will not permit here. And next is the when T2 transaction will wants to again locking in the shared mode, then it will be permissible because shared log can be given to more than one transaction simultaneously. Right? Now, exclusive lock. Exclusive lock, when we want to update the data item, read as well as write the data, then we will use exclusive lock. With the exclusive lock, a data item can be read as well as written. This is exclusive and can't be held concurrently on the same data item. X lock or exclusive lock is requested using lock X instruction. Transaction may unlock the data item after finishing the write operation. Okay. For example, these are the two transactions T1 and T2. When a particular transaction lock a particular data item, for example A, what it means, this transaction T1 will wants to update the data item A. Okay, so when we want to change the value of the A or update the value of the A, we need a lock in the exclusive mode. If we lock the data into the shared lock, then it is not permissible. Okay, but now again, if the T2 wants to exclusive lock on the A, if already T1 have the exclusive lock on the A, then this is not possible. Okay, so we can see here, this is the lock compatible matrix. So you can see here in the compatible matrix, this is the shared and exclusive lock. Okay, if the one transaction is in lock a particular data item in the shared lock, then another transaction also can lock a particular data item into the shared lock. That's why it is a true. But if a transaction lock a particular item into exclusive lock and another again second transaction or T2 transaction wants to it into the shared lock, then it is not possible. Fine. In this way, if a particular transaction lock a particular data item into shared lock and another transaction T2 wants to data item into exclusive lock, then again it is not possible. Another condition is that when a transaction T1 wants to lock a particular data item into exclusive mode and again T2 wants to this data item into lock into the exclusive mode, then it is not possible. So you can see here only the case of the shared locking, the two transactions simultaneously can lock a particular data item. Otherwise, it is not possible. So this is the locking concept of the protocol, where a particular data item can be locked by a particular transaction. And when the operation will be done by the transaction, it will unlock the data item, and other transaction also can use these data items. Right? So this can remove some problems of the concurrency control. Now next is the two-phase locking protocol. A transaction is said to follow the two-phase locking protocol if locking and unlocking can be done in two phases, growing and shrinking. New locks on the data item may be acquired, but none can be released. Growing phase is that phase of the transaction when the transaction is acquiring the lock on the different type of data items. Fine. But in the shrinking phase, existing lock may be unlocked, but new locks cannot be acquired. So there can be two phases for the locking or unlocking. When we are going to lock all the data items, then this is known as a growing phase. Fine. Then it is known as a growing phase when we are locking all the data items. But there will be a lock point where we will completely lock all the data items. Then there will be a shrinking phase. Here what will happen? Here we will unlock the data items. Now no data item can be locked in the shrinking phase. If the shrinking phase will start after the lock point, then what it means, now no data item will be locked again. Okay, now the unlocking is started. Now you can see by the help of this example, we can understand it. This is a transaction begin and this is the growing phase. This is known as a growing phase where transaction is going to lock the particular data items. And after this, we can this is the transaction. Okay. Or you can say this is the lock point where we have completed all the locking of the transaction. Now, after the completion of the transaction, we will start here shrinking phase. In the shrinking phase, what will happen? All the locks will be released by the transaction so that other transaction can use this data types. Right? Now, with the help of this schedule, you can understand the concept of locking, two-phase locking. You can see here, this is a transaction 1 where data item A is locked by in the shared mode. Fine. Next, another lock and B data item is locked in the exclusive mode. So, this is known as a growing phase of your transaction T1. Now, after the complete of the locking and after executing all the required operation of the transaction will start the unlocking of the data items. So now you can see here, this is the shrinking phase of the data item of the transaction. This is the T1 for the T1. This is the growing phase and this is the shrinking phase for the T1. Now we will see here for the T2 transaction. You can see here firstly, it will lock in the shared mode A data item. It will be permissible because already T1 have already locked the data item A, but because it is in the shared mode and again T2 again require the data item in the shared mode, then it will be permitted. Now next instruction is lock exclusive C, because in this case we don't have C data item, so easily we can T2 will get the lock on the C data item. So you can see here from here to here, from 1 to 5, it will have a growing phase because it is acquiring the lock on the different data items. Now you can see here, after that transaction will unlock the data items. Then it is known as a shrinking phase. So now I think you will understand very easily what is the meaning of shrinking and growing phase, which is very important, two phases in the two-phase locking protocol. Now, next is two-phase locking protocol. Firstly, this is the type of the two-phase locking protocol. First one is the strict two-phase locking protocol. In this protocol, a transaction may release all the shared lock after the lock point has been reached, but it cannot release any of the exclusive locks until a transaction commits or aborts. It ensures that if data is being modified by one transaction, then other transaction cannot read it until first transaction commits. This protocol solves dirty read problem. The dirty read problem is a major problem in our concurrency control. So, by the help of strict two-phase locking protocol, we can remove this dirty read problem. Okay. Now, next is the rigorous two-phase locking protocol. In this protocol, a transaction is not allowed to release any lock, either shared or exclusive, until it commits. Right? So, commitment of the transaction is very necessary for the rigorous two-phase locking protocol. This means that until the transaction commits, other transaction cannot acquire even a shared lock on a data item on which the uncommitted transaction has a shared lock. Okay. So in this case, rigorous two-phase locking and not neither read or neither write operation is possible without commit operation of a particular transaction. Right? This is known as a rigorous two-phase locking. And the third type of, so this is the first type is strict two-phase locking. Second type is rigorous two-phase locking. And third type is conservative two-phase locking protocol. So we have mainly three types of two-phase locking protocol. It is also known as a static 2PL. By pre-declaring its read set and write set, this protocol compels the transactions to lock all the items it assesses before it begins execution. Okay, so it will lock all the data item which it requires at the time of operations. So it will lock all the data items before the beginning the execution. This is known as a conservative two-phase locking protocol. The transaction locks none of the data if any pre-declared objects cannot be locked. And instead it waits until all the items are ready to be locked before proceedings. So, and this protocol will remove the problem of the deadlock in the concurrency control. Fine. Now, next type of protocol is timestamp based protocol. Here we are using time for the particular transaction. For example, T1, we have the first transaction is T1 and it comes to execute at the time of 3 o'clock, for example. So, this is the timestamp of a particular, we will give a timestamp to a particular transaction. It can be a value or it can be a time. At that time, it come to into the system. So, for example, here T1 comes at 3 o'clock. So, we can say this is the timestamp value of T1. Now, T2 will come 3:10. So, we can see that T1 is the older one than T2 timestamp, T2 transaction, because the timestamp value is greater than T1. So, we can see here T1 is the older one and T2 is the younger one transaction. Fine. So, this timestamp value based protocol works on this concept. This protocol uses either system time or logical counter to be used as a timestamp. Every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. A transaction T1 created at 0002 clock time would be older than all the transactions which come after it, which I have already explained to you. For example, any transaction T2 entering the system 004 2 seconds younger than the transaction T1, and priority is given to the older transaction every time. Right? In addition, every data item is given the latest read and write timestamp. Okay, so firstly we should understand this thing. Every transaction will have a timestamp value here, and after that each read and write, there should be a data item which have a read and write timestamp value also. Transaction will have a timestamp value and data item will also have a read and write, latest read and write timestamp value. Latest read and write timestamp value means, if for example we have a data item X. What it means, the latest read by a particular transaction, the timestamp value of that transaction will be the read timestamp value for this transaction. Any transaction which have latest read of this X item, that is the timestamp value of read timestamp value of the X. In this way, a particular transaction have latest write of the value of the X. That is known as a write timestamp value of the data item X. So, we have three main things here, main important points here. In the case of timestamp based protocol, firstly, the timestamp value of transaction Ti, which is denoted by TSTI. Okay, so this is the timestamp value of the transaction. And the next important thing is read timestamp of the data item X. It is denoted by read timestamp X. So, latest read by a particular transaction. The timestamp value of that transaction which have latest read of the data item X is known as a read timestamp value of X. In this way, Write timestamp value of the data item X is denoted by W timestamp or X. Okay, so we will have 3 timestamp values with the in this timestamp value. One timestamp value for the transaction and 2 timestamp value for a particular data item. Now, we will see what are the main rules for the timestamp. This is the responsibility of the protocol system, that is the conflicting pair of the task should be executed according to the timestamp value of the transaction. Okay, so we should have this 3 points again. I am told you timestamp value of the transaction, read timestamp of the X, and write timestamp of the X. Now the rules for the timestamp ordering protocol. The timestamp ordering protocol works as follows. If transaction Ti issues read operation, for example, any transaction T1 issues a read operation, then we will check its timestamp value. If the timestamp value of a transaction, for example, we have here T1 transaction. So for the T1 transaction, timestamp value of the T1 transaction is less than of the right timestamp value of X, then operation will be rejected. Okay. Now, next is the timestamp value of Ti is greater than or equal to right timestamp value, then operation will be executed. This is a rule for the read operation. If a particular transaction wants to read a particular read operation, wants to perform the read operation, read X, then we will check this condition. If the timestamp value of the Ti is less than the right timestamp value, then it will not be allowed. If it is greater than the right timestamp value of X, then only operation will be executed. Okay. So we will not allow the older read operations in this case. You can see here by the help of this rules we can find out that we cannot allow the older read operations from the transaction. Okay. Now next is the if a transaction Ti issues write X operation. Now another rule for the write operation. If a particular transaction, for example T1, wants to write a write operation on the X data item, then we will check the timestamp value of the Ti less than of R timestamp X, then operation will be rejected. Fine, because this can be a older operation, because the value of the read timestamp value is more than timestamp of the transaction. So this is the older operation. Again, second we will check for the timestamp value of the transaction less than from the right timestamp value of the X, then again operation will be rejected. So what it means? Write operation can be conflict for the read and write both. So we will check the write timestamp value as well as read timestamp value, and the transaction timestamp value should be greater than these values. Then only operation will be executed. Otherwise, otherwise operation will be rejected. Fine. So these all are the timestamp based protocol, rules of the timestamp protocol. So we have in this lecture we have discussed all the concurrency. What is the meaning of concurrency? What are the major problem of the concurrency of the different transaction, and how we can remove these problems, and different type of concurrency control protocol we have discussed in this case, which are the main and major protocols: the two-phase locking and timestamp locking, timestamp protocols. So I think you have understand easily these protocols. Okay, thank you.